Hi everybody, this is going to be our second summer work review video. Again, I'm going to go quickly through these problems, pause, try them yourself, and then play and see if you got it right. So we're going to start off with the same kind of thing we were doing in the last video, domain range, and then determining if the relation represents a function. So we're going to look at two of these and then do something different. Now this is a discrete graph because the points aren't connected, but we can still do domain, range, and determine if it is a function. Now it might be helpful to maybe label all of these points because the x and the y values from those coordinate points are going to make up our domain and range, right? So we've got the point 1, 3, 2, 1, 3, negative 1, 4, 2, 5, 0, and all the way up here we've got 6, 6. So my domain is literally just listing all of the x values of those points that we just labeled. So we have x values of 1, 2, 3, 4, 5, and 6. And for my range, I'm just going to list all of the y values from those points. We had negative 1, 0, 1, 2, 3, and 6. So that's it for domain and range. Now I'm going to erase these points here because we need to do our vertical line test. Okay, if I draw a vertical line, I need to make sure it's only crossing through one point at a time. And we can see if I test every single point on here, it's only going to cross one at a time. So yes, this represents a function. Even though it's discrete, it's still a function. Okay, here's another. Okay, let's do domain and now notice we have arrows on the right ends of this graph. So it's going forever to the right, but we have a leftmost x value of 0. So the domain is going to be x values greater than or equal to 0. Okay? Starts at 0 and goes to the right forever. For the range, as this bottom arrow is moving to the right, it's also going down forever. This arrow, as it moves to the right, is going up forever. So really, our range spans all real numbers, everything from negative to positive infinity. So our range, all real numbers. This is the first one we've seen, though, that fails the vertical line test. It crosses two places multiple times on the graph, okay, but even just that happening once is enough to make this not a function. So let's move on. Okay, let's talk about some line stuff, some linear equation stuff. Okay, if I want to rewrite this equation in slope-intercept form, which is my y equals mx plus b, I really just need to solve this equation for y. Get y by itself, and it should go to slope-intercept form. So I'm going to subtract 4x first. Then I'm going to divide by negative 3. And there you have it. Okay, slope-intercept form. The slope is 4/3. The y-intercept is negative 4. Okay, so solve for y. Okay, here's a graph, and we want to write the equation for this graph in, once again, slope-intercept form. Super easy to do. All I need to find is the slope and the y-intercept from looking at this graph. The y-intercept is at 2. Okay, so we already have that part. The slope is, let's see, we go up 3. We go over 4, so rise over run gives us a slope of 3/4. So our equation is y equals 3/4 x plus 2. All right, let's talk about slope formula and point slope form. Okay, if I want to write an equation for the line in slope-intercept form for the line that passes through the points 1, negative 4, and negative 3/8, I need to do a lot of work before I can actually get it into slope-intercept form. First of all, I don't even know the slope. So let's label these points x1, y1, x2, y2, and let's throw it into our slope formula to find the slope here. So remember the slope formula is y2 minus y1 over x2 minus x1. which is going to give us -3. So we have our slope, okay? But I don't know my y-intercepts. So I need to use point slope form, okay? Point slope form is y minus y1 equals m times x minus x1. I need to use this formula, and then I can solve for y and get my answer in slope-intercept form. So let's go ahead and throw some stuff in here. Y minus y1 is equal to our slope that we just found times x minus x1. And then from here, I am going to just start cleaning this up. I'm going to distribute. I'm going to subtract 4 from both sides. And now we have an answer in slope-intercept form. All right, let's talk about parallel and perpendicular. Okay, we have an equation. We want to write one equation for a line that would be parallel to the equation that we're given, and one line that would be perpendicular. Now, parallel lines have the same slopes, and perpendicular lines have opposite reciprocal slopes. So we need to find the slope of this equation before we can do anything else, right? We need to get y by itself. We need it in slope-intercept form so we can recognize that slope. So I'm going to subtract 2x from both sides first. Then I'm going to divide by -1. So we know that the slope of the original equation is 2. Okay? If I want an equation parallel to that, I just need to write an equation that has the same slope. It doesn't tell us that it needs to go through a specific point, so you can choose whatever y-intercept you want as long as it's different than the one from the original equation. So I'm going to say 2x plus 1. All right? Now, for perpendicular, we need opposite reciprocal slopes. Okay, well, the opposite of a positive is a negative, and the reciprocal of 2 is 1/2. So we need to use that slope of -1/2 for our perpendicular equation. Again, the y-intercept does not matter, so I'm going to do -1/2 x plus 4. And there we go. We have a parallel and a perpendicular line to that original equation. Now we're going to wrap up with some systems of equations here. Pay attention to what method I want to use. So here I want to use elimination. So we need to decide if we're going to add or subtract these two equations. Okay, well, I think the x's are probably going to be easiest to cancel out because they have -3 and +3 as the coefficients. So we need to add these two equations together to make those x's cancel. Okay, if we add -3x plus 3x, those cancel. -4y plus 3y gives us -y. 2 plus negative gives us -1. And then we can divide by the -1 on each side to find that y equals +1. Now we just need to plug that y value into one of our original equations here. I'm going to use the bottom one. So 3x plus 3 times 1 equals -3. So we find that x equals -2, y equals 1. We always need to express our solution as an ordered pair. So -2, 1 is our answer. Let's look at substitution. Okay? We need to decide which of these equations we're going to solve for a single variable. Remember, you want to always look for the variable that doesn't have a leading coefficient, or I should say a coefficient of 1. In this case, it's going to be the y. Okay? So I'm going to solve this top equation for y. I'm going to add 2x to both sides first, and then I'm going to have to divide by -1. So we get y equals -2x plus 9. Okay, so there is my first equation, my top equation solved for y. Now I'm going to take this and substitute it into the second equation. I'm going to take what y is equal to, and I'm going to plug it into the y right here. So we have 5x minus 2 times negative 2x plus 9 equal to 18. And then I'm going to solve for x. And we find that x is equal to 4. Now I'm going to take that x value, I'm going to substitute it back up here and find what y is equal to. So we found that x is equal to 4, y is equal to 1. Now we just have to write that as an ordered pair, and we are finished. All right, guys, I hope this was helpful. Please let me know if you have any questions, and have a wonderful day.